All right. Good afternoon, folks. My name is Sean Sanders. I am the global head of data science at RandstadSourceright. And today I'll be talking about how we overcome some of the data modeling challenges for AI problems in the HR services industry. So, a little bit about Randstad. We are the largest provider of human resources services globally, and we're actively building the world's most equitable and specialized talent company. Um, what does that mean? We are a people and talent centric company. When you think about our industry, a little bit about the type of data that we have. So HR services data, obviously there is some job posting and assignment data associated with that. So advertisements for whatever positions that you want to hire for. There are also candidate profiles and resumes. So people putting themselves out there with their information on how they're qualified for certain positions. And then, of course, our customers and clients. We have certain information related to that, such as work sites and things of that nature. There are some key properties of this data that we must take into account when we're modeling for these different situations. The first one is that it's personal. Obviously, human data is indeed personal, and we need to be cognizant and aware of these types of impacts. Second is unstructured. We're dealing with text and video data and image data. And lastly, it's impactful. We're talking about jobs here. So that means we're dealing with people's livelihoods and also a core part of many folks' identity as well. So there are some core challenges and responsibilities that we look into. And I like to break this up into two key areas just for brevity. The first, from a data architecture and processing perspective, AI and data are inherently inequitable. So there definitely needs to be some type of framework or architecture in place which can overcome some of the challenges with data protection and privacy, algorithmic bias, but also making sure that our approach serves our domain experts, clients, and talent, and we have some continuous monitoring and validation in place on top of that. Without this, then it's really difficult for you to build models that can solve our core problems in a sustainable and scalable way. Once we have this, the next part is the data science applications themselves. For us, that means several different areas that are fairly common in the industry, from just supply analysis, demand analysis, hires data, hiring freezes, taxonomies for classifying different job titles and roles, and career pathing data, compensation. How do you deal with these things? And the interesting part about the data science apps is that they all feed upon each other, right? If you go up and change your compensation, then that might have an impact on whether someone stays or leaves your particular company. To start out, let's talk a little bit more about the AI framework, specifically the data privacy bit. And this isn't something that we made up. This has been legislation been going on across the globe for many different years, whether you're thinking about GDPR or the AI Bill of Rights. User privacy and their personal data is definitely very important. In addition, not just the legal constraints, there's also just the ethical concerns about using this data in general. Our approach to doing this, in order to address this in a responsible manner, one of the first things we did was just identify and classify the different types of data that was available to us. So whether you're thinking about direct identifiers that easily identify folks, say your name, your social security number, email or phone number, or quasi-identifiers like your age, gender, or race, or your location, you need to treat this information differently because downstream, the type of approaches and models that you use require somewhat different attention. Not that everything isn't sensitive or identifiable. This is just the order in which the community has decided to organize this data. From an algorithmic perspective, depending on how we want to categorize the data, this is just an example of different techniques that we've leveraged in the past, either from a taxonomy perspective. So if you have a location, I live in Sandy Springs, hence the example up there, Sandy Springs, Georgia. Instead of putting something specific, we'll put something more general, something that's more difficult to identify. Or even a job title. Is it a data analyst per se, or is this more just a data professional? And that's the level of granularity that we want to provide. or the company name, right? Do you want to put the company employer name specifically, or do you want to say the industry? Because this is easy to identify. This might seem subtle, but it's important. If we're talking about employment data, data that is available on a website, right, like LinkedIn, if you have somebody's job title and their date that they started, maybe even their employer, you can identify them. It's very sensitive, especially once their salary is involved there. Going down to other techniques, discretization, either you're generalizing someone's age or their salary, or even something more basic as a one-way hash to just mask someone's name or their resume. Many different approaches that are available for you to protect user data that we should be leveraging as we build robust systems. To go back to the impact and the reason why we're doing this, de-anonymization is a real issue, right? And when I say about that is, if you have someone's personal information or their information, the risk is really being able to re-identify that person. What's the risk associated with that? And this is a common statistic that you'll see. If I know your birthday, your zip code, your gender, then there's like a ridiculously high probability that I can re-identify you. Couple that with things like LinkedIn for staffing data, then it's a major problem that you need to overcome and address in some way. So to address this, we decided to combine traditional anonymization in addition to something that we call a privacy model. And this is also something that exists. K-anonymity is probably the simplest privacy model out there. So if I'm given a particular individual, say Bob, for example, and his zip code is 47678, age 27, and their job title senior data scientist, we'll mask this data to hide some components of their zip code and their age and their title and provide a range for their salary just so you can't easily identify this person. This isn't foolproof, bulletproof, right? There's still some risk here. For example, there are 3 people who fit into this bucket similar to Bob, and there's risk there because this also says that all of the data professionals at this particular data set has a salary between $90,000 and $110,000, which is a leakage, right? All of it being the same is a problem. So when you deal with models like this, there's obviously ways that can happen that this information can leak, and we must be at least aware that these things can happen and to develop models and approaches that allows us to be robust to some of these attacks. On a similar case for the Carl example, this is an example where not all of them have the same salary. They're all forklift in some regard, but one of them has a salary between 20 and 30K. But what if you knew that one person had a salary between 20 and 30K? That means I can re-identify Carl, right? So even if we do some of the things that we imagine is beneficial, we must always be aware of these cases where people's privacy and their data is at risk. And again, when you're dealing with HR and human data, when you have data like LinkedIn that you can easily access, or even H-1B data, this is a huge risk that we must take into account. So when you mix anonymization and privacy models together, it doesn't necessarily come together boxed for you. Usually you'll talk to an anonymization vendor and they'll say, hey, what fields do you want to anonymize? And one-way hash or some other trick that you use to make your data more secure. But if you want to combine the two, you need some type of resolution strategy to overcome that. And one approach that you can use is something called a constraint satisfaction model, a CSP. 2 famous problems like the 8 queens problem, say you want to orient 8 queens on a chessboard such that they don't collide and take each other. Or if you're doing map coloring, which is another constraint satisfaction problem, you can use this framework to solve this very problem, right? So if you're given a data set and you have strategies to resolve or make things more private, whether you're reducing the granularity of a job title or the granularity of a location, you can do this until your constraints are satisfied. So you have a certain number of duplicate records in your data, or minimize your risk of homogeneity attacks or things of that nature. So this is one way in which we've looked into protecting user privacy when it comes to HR data. Now I'll shift gears, talk a little bit about algorithmic bias, and start from a toy example. So if you're given HR data, say you want to match candidates to a particular job, classic HR problem. So if you have a corpus of resumes You want to rank these resumes according to their fit for a particular role. You might take this input data, you'll tokenize it, take out some terms of interest, say Hostess, Bar Taco, Miami, Florida, certain tools that folks have been using. And obviously there's some bias risk associated with this, either your employer, the location, or even the job title itself. But there's techniques that you can use to help overcome this bias, one of which is data augmentation, where if you see Hostess, which has a gender bias, you can add host, which kind of counteracts that bias, right? Or you can do taxonomy or generalization, which is similar to the anonymization use case, where you take not just Bar Taco as a restaurant name, but you just put restaurant industry there, which is associated with your employer. Or you can just remove data sources as well, like location. Does that have a strong association with at least being qualified from a skills perspective with that particular job? Maybe from a location requirement that's different, but from a skills perspective, maybe you want to approach that differently. And then downstream, once you've cleaned up this data through pre-processing, you can leverage whatever algorithm that you want, right? And we're hoping that something like this is beneficial, whether it's a learning to rank algorithm, or you do deep learning, or take a generative AI approach. Such methods like this tend to apply across the board. So where does some of this precedence and motivation come from? Well, there's the EEOC, which has established certain protected subpopulations, such as race, gender, and age. And then there's the 4/5 rule, which has set more of a quantitative measure of measuring whether or not you have the selection rate has presented an adverse impact to a particular group, right? And these are things that we kind of begin the whole quantitative measure to determine whether there's adverse impact onto a group, and the metrics that you use can become complex. I believe there are dozens and dozens of different metrics. So when you create this loop, many of us have seen this loop, user interaction, data, algorithm, and then you're thinking of what metric you want to use, whether it's equal opportunity, which is looking at from a true positive perspective, or demographic parity, or equalized odds. There are quantitative metrics that can help you measure bias and fairness. But one thing I want to call to your attention is more of a qualitative metric as well, right? Because take the example over here, the plot in the upper right-hand corner, where you have years of experience on the x-axis and you have resume score on the y-axis. If you just follow the data and you let your model fit the data as best as you can, you'll see that as you get more years of experience, sometimes the resume score will get lower. And that's not fair, right? Even though if you run a model and your metrics come out from a qualitative sense is the result, that's not fair from a intuitive or qualitative sense. So how do you overcome that? Well, you can use constraints to say, well, more years of experience should not hurt your candidacy for a role, right? There was a paper that was published a few years ago, which more or less applied this constraints to the data set, and making constraints such as this is enough to improve fairness in your models, right? And what if you do this at scale? So it's not just this quantitative battle of scoring and weights. Sometimes it's more of a intuitive, common sense type approach. It's like, hey, experience should not hurt you, and just forcing those constraints into your model and building it from there. So that kind of leads us to our high-level methodology that we use for Fair AI. So if we take an input data set, use certain methods for pre-processing and tokenizing the data, certain feature selection methods, say fairness through unawareness, getting rid of all the features that are correlated with a protected attribute, right? And their correlated features where possible. Say from a pre-processing perspective, if there are sensitive job titles like host versus hostess, can we overcome and improve that? From an in-processing perspective, right? Can you put constraints in place like monotonicity, or even making sure that features can't be negative, like a skill cannot hurt you from being qualified from a certain position? Is that something that we can do? Last but not least, I don't want to overlook the importance of manual curation and that human in the loop piece as well, right? There's only so far that we can get by relying on the data and the models and the constraints. There needs to be some manual override to improve the performance of these particular models, right? Now I've talked about some of the challenges. I'll talk about a little bit more of the algorithms and the problem spaces, and I'll begin with attrition analysis, which is interesting. So there's a few sub-problems that you can define for attrition analysis. Typical asks that we get are, market rates for a given job title and location, right? So how much are you paying your accountants in San Diego, California? And sometimes we have to give different rates. There's a full-time permanent employee rate, and then there's a contingent rate. And then there's different levels of experience, junior, senior, highly skilled folks. And sometimes we're not even looked to give a rate for a particular job title or location. We're looked to give differences in compensation across different regions. So how much do people make in San Francisco versus Atlanta? And there's many challenges dealing with this. There's availability of data. There's also taxonomy. So if you have job titles from company A and company B, they're very similar, but they're not the same. How do you align those together? Skills-based compensation. If you have a certain key skill, how much more compensation should you make due to having that skill? And also transformation of different rates. Sometimes it's easy to find temporary compensation rates. Sometimes it's not. Sometimes all you have is a full-time rate and people want the temporary rate. How do you do that transformation? Many different issues associated with that as well. Also on the attrition side, there's career pathing. So if you're losing talent to a particular competitor, there are two problems you can look at. Career pathing, so moving from one job title to another job title, or there's talent mobility, so moving from one company to another company. So on the left, you'll see feeder jobs, which goes into the middle job, data scientist, just as an example. And then on the right, you'll have kind of jobs that the data scientist goes to. And this is a typical example. The best way to become a data scientist is to be a data scientist, right? How do you get into the field besides that? Data analyst, research assistant, or other jobs you can do. Maybe go to school, be a grad student, get an internship. That's the way to get into the field. And after you become a data scientist, there's a certain probability you'll become something else. So this is one example that we can use to do career pathing. One thing I would emphasize is that this relationship isn't always as clean. You'd be surprised how often accountants go into tech fields and folks are looking for talent in other areas because there's a shortage. So using models like this is an excellent way for us to determine where you can get that fringe talent that may even cost less to bring them on board and train them up to have an impact on your particular organization. So just to go on with be cognizant of time a little bit, from a attrition analysis, we look into these things. If folks are leaving, where are they leaving to? What roles are they joining? And what is the compensation associated with these things? And based on analysis, we can give recommendations to our clients on what they can do or what interventions they can take to address the issue. And sometimes it's career coaching. Other times it's compensation related. The next bit I'll talk about is more of a what-if analysis, dynamic system modeling example. So if you think about the hiring process, there's different steps that goes into that process. Whether you're creating a rec and you're submitting an application or you're interviewing someone all the way down until someone gets onboarded, there's different steps to that process. And there's two things we need, an inter arrival time between events and a probability of an event. And we need to take into account all the dynamic external factors like supply and demand and budget and things of that nature, right? So if we have that, we can model the interrelationships and the arrival times between events and the probability of events happening. So if somebody makes an offer, what's the probability of them actually accepting it? And what's the probability of them actually showing up the next day for their job, right? Or are they gonna ghost a particular job, which is a common thing, right? So we deal with this sometimes. We've built systems which allows us to model certain situations. Say if you have a certain number of recruiters and you want to predict a certain number of hires that you want to have, we can forecast what we expect to happen given those resources and what actually happens. And sometimes we find discrepancies, right? Sometimes we would predict a value that doesn't align with expectations, and we need to understand why. One common scenario we ran into was we didn't model, for example, the impact of experience on the productivity of a recruiter. And once we're able to do that, we can better predict the performance of our organization and meeting our benchmarks. So to wrap up, I just wanted to talk a little bit about some of the challenges we see in the HR services industry, both with respect to data and trusted AI, but also with respect to some of the modeling challenges that we have and some of the problems that we run into. I hope you enjoyed this presentation. If you have any questions, I look forward to connecting with you. Thank you.